Lesson 33, Conditions for Special Parallelograms. The objective is to prove that a given quadrilateral is a rectangle, rhombus, or square. Last lesson, we learned all the properties for rectangles, rhombuses, and squares. This lesson is kind of using the converse. If we're given a condition, then we can decide what kind of quadrilateral it is, or if it's a parallelogram, if it's a rectangle, if it's a rhombus, or a square. So we remember the other conditions. We had the fact that if it was a rectangle, it was automatically a parallelogram. 6.5 and 6.2 are kind of going backwards. If one angle of a parallelogram is a right angle, then the parallelogram is a rectangle. If the diagonals of a parallelogram are congruent, then the parallelogram is a rectangle. Let's look at an example. A manufacturer builds a mold for a desktop so that AB is congruent to CD, BC is congruent to DA, and the measure of ABC is 90 degrees. Why must ABCD be a rectangle? Well, both pairs of the opposite sides of ABCD are congruent, so ABCD is a parallelogram. Since the measure of ABC is 90 degrees, then one angle of a parallelogram is a right angle. So, by theorem 651, ABCD is a rectangle. These are the conditions that tell us whether or not a parallelogram is a rhombus. 653, 654, and 655. So we're talking about some sort of parallelogram with a certain condition, and if that holds true, to become a rhombus. So if one pair of consecutive sides of a parallelogram are congruent, then the parallelogram is a rhombus. So this is where consecutive sides are congruent. If the diagonals of a parallelogram are perpendicular, then the parallelogram is a rhombus. If one diagonal of a parallelogram bisects a pair of opposite angles, then the parallelogram is a rhombus. So these are like the converse statements that we had from 6.4. In order to apply theorem 651 through 655, the quadrilateral must first be a parallelogram. So we can have all of these conditions, but if we don't know for sure that we have a parallelogram, we can't say what kind of quadrilateral it is. To prove that a given quadrilateral is a square, it is sufficient to show that the figure is both a rectangle and a rhombus. Remember, you can also prove that a given quadrilateral is a rectangle, rhombus, or square by using the definitions of the special quadrilaterals from last chapter. So let's look at another example. Determine if the conclusion is valid. If not, tell what additional information is needed to make it valid. And then we're given that in this quadrilateral, EF is congruent to FG, so EF and FG, and EG is perpendicular to FH. Our conclusion then is that EFGH is a rhombus. The conclusion, however, is not valid. By theorem 653, if a pair of consecutive sides of a parallelogram are congruent, the parallelogram is a rhombus. And 654 says the diagonals perpendicular of a parallelogram would make it a rhombus, but we don't know if that EFGH is a parallelogram first. So we can't say for sure that it's a rhombus. Again, we want to determine if the conclusion is valid, and if not, tell what additional information is needed to make it valid. So we have another quadrilateral, EFGH, and we are told that EB and BG are congruent, FB and BH are congruent, EG is congruent to FH, and that triangle EBF and EBH are congruent. Our conclusion is that EFGH is a square. Step 1, we want to know if it's a parallelogram or not. So we're given EB is congruent to BG and FB is congruent to BH. Quadrilaterals with diagonals bisecting each other are parallelograms. So EFGH is a parallelogram. So step 2, we want to find out if it's a rectangle. EG is congruent to FH, that's given. Parallelograms with diagonals congruent are rectangles. So EFGH is a rectangle. Step 3, determine if EFGH is a rhombus. Well, triangle EBF is congruent to EBH. That means that EF is congruent to EH. And a parallelogram with one pair of consecutive sides congruent is a rhombus. So EFGH is a rhombus. We want to decide now, is it a square? Well, since EFGH is a rectangle and a rhombus, it has 4 right angles and 4 congruent sides, so EFGH is a square by definition. The conclusion is valid. Let's look at this in a coordinate plane. Use the diagonals to determine whether a parallelogram with the given vertices is a rectangle, rhombus, or square. Give all the names that apply. So step 1 is to graph this parallelogram, PQRS. So we make a graph. Step 2, we want to find PR and QS to determine if PQRS is a rectangle. So the distance formula tells us that PR equals the square root of 26 and QS equals the square root of 26. Since the square root of 26 is equal to the square root of 26, the diagonals are congruent. PQRS is a rectangle. So now we want to find out if PQRS is a rhombus. The slope of PR is equal to negative 1/5. The slope of QS is equal to 5. Since negative 1/5 times 5 equals negative 1, which tells us these are opposite reciprocal slopes, then PQ is perpendicular to QS. PQRS is a rhombus. And then we want to determine, is it a square? Well, since it's a rectangle and a rhombus, it has 4 right angles, 4 congruent sides, so PQRS is a square by definition. Let's look at another one. First, we want to graph WXYZ, so we graph it. If we trust our eyes and just look at the graph, we can see that this is definitely not a square. Step 2, find WY and XZ to determine if WXYZ is a rectangle. WY is equal to 3 square roots of 2, and XZ is equal to 5 square roots of 2. Since they are not equal, not congruent, then it is not a rectangle because the diagonals are congruent in a rectangle. Thus, it is not a square. Well, is it a rhombus? If we look at the slope of WY, we get negative 1, and the slope of XZ is positive 1. That gives us a negative 1 result, which means they're opposite reciprocals, which means that the diagonals are perpendicular, and WXYZ is a rhombus. Now you try. You're going to determine whether the conclusion is valid or not for 1 and 2. For 3 and 4, you want to also determine whether the conclusion is valid or not. And if not, tell what additional information you would need to make it valid. And then you want to graph these and determine whether a parallelogram is a rectangle, rhombus, or square, and give all of the names that apply.